Hi guys, I hope you all are doing good. Welcome back to another session of performance testing and engineering concept. In this session, we will be talking about some more concepts related to performance testing, what are the common terminology we have and how to define them. So today I have these topics which I will discuss with you and try to make you understand with some example. So the very first thing is functional versus non-functional. I hope some of you who are working in functional or automation domain may be knowing what is functional testing, and you might have some basic idea about even non-functional or performance testing. So let us try to understand it. When we do functional testing, our main focus would be on the outcome, how the results would be. If I'm going to hit Google, am I going to get Google homepage? If I'm going to hit Flipkart or Amazon portal, am I going to get the right page? So the actual result, are we going to get the right result when we do functional testing? That is the main goal. We never ever think how long it will take. We never think how fast the content being getting loaded, right? And that makes a difference between functional and non-functional testing. On the other side, in non-functional tests, what we are going to measure is when I'm going to hit Google, how long it will take to get me the Google page. Is it going to take 1 second? It's going to take more than 2 or 3 seconds. So that will be our goal. So if I differentiate functional and non-functional testing, functional testing focus mainly on the output or outcome, the exact output we should get. But in non-functional requirement or testing, we will be focusing mainly on the time. So this is not the only goal. We will learn few more things. But as of now, you understand the response time is the key criteria in non-functional testing. Now, when we do performance testing, we have some template defined and some of the terms are written here. For example, transaction. So what do you mean by a transaction? Let's again try to understand with the help of a functional flow. Let's just say you have an e-commerce application where you are going to search for some items or products and try to add to your cart. So what will be the functional flow? You are logging into the e-commerce application, then you will get a home page. You will search for the product, you will select that product and then you add to your cart. So this is very simple example. Nowadays we all are doing online shopping at Flipkart or Amazon, and we know how we are doing shopping, right? We do see the items, we select the items, we add to cart, we do the payment, and we do checkouts or place order, right? So let's assume this is my flow where we are going to add one item to our cart. Now there are steps involved. The very first step was going to home screen or home page. Second was searching for the product. Third was you are selecting a product and adding to your cart. That is the last one, right? So all these steps we define in performance testing as transaction. Home page, clicking on home page is one transaction. Searching a project is second transaction. Selecting a product from the available product is another transaction. Adding a product to the cart is one more transaction. So transaction is nothing but the steps you perform in a functional flow. We name it as a transaction. We always start a transaction, and once that step is completed or we will get the result, we will end that transaction. So this is part of the scripting template in performance testing. Now what is think time? Whenever we do any functional flow or in normal life also, if you are going to do some shopping online, what do? You first think of which e-commerce platform is providing some kind of sale or good deals. So you take some time to think about it. Should I go to Amazon? Should I do the shopping on Flipkart? So whatever time you take to think and then click on a link, we define it as think time. Basically, this is the time taken between two steps. Let's just say I click on the home page of Flipkart and then I want to click somewhere. I'll take some time. Let's just say 2 second time, 2 to 3 seconds to think whether I should search or click on a link or click on a video. So the time you take to think and then do a clickable action will define our think time. So basically it's a time of delay between two steps. Now what is pacing? Pacing is another delay, but that will get introduced at the end of the flow. For example, I explained you add to cart flow. So once you complete add to cart, and if you introduce some delay at the last step, which is add to cart, and you insert that, so what will happen when you run this particular flow or script in performance test? It will come, complete an entire flow, pause or stop for the given time which you define as pacing at the end, and then start from the very first step again. So pacing has its own significance, which I'll define later, but as of now, I would say pacing has a very critical role to control your throughput. Now, there are few more terminology we use: ramp up, steady state. They are basically related to the test. When you run a test, what is ramp up or ramp down time? So let's just assume you are going to conduct a test where you want to run it with 100 users. So as I said in my previous sessions also, it is always a good practice to run step by step. Don't you ever run all 100 users together and stress out your system, because it might fail, it might run into errors, and you have to investigate a lot of things. So what would be the best approach here? You take 5 users, add them to your flow, and then after a few seconds, let's just say after 5 seconds, add 5 more. After another 5 seconds, you can add another 5. So like that, step by step, you are going to add five users every 5 seconds. So it's not necessary to run it every 5 seconds. You can give however you want to design your scenario. You can do a ramp up for 2 seconds, you can do ramp up for 5 seconds, you can do it for 10 seconds based on your business requirement. So ramp up is step by step adding of users, and you define the time altogether. You have to calculate, like for 100 users how many seconds I need, and you give that when you design a scenario. What is a steady state? So once all these 100 users are getting into the application or they are into the system, right, they will continuously do some or other work. So once you reach a state where all 100 users has come, from there onwards, whatever duration you specify to run the test, let's just say 1 hour or 45 minutes, they all 100 will be running the test altogether. So the duration what you define when all users have already ramped up is defined as duration or steady state. So whenever we prepare our test result, we always focus on steady state. We never consider ramp up. Ramp up is just to initialize the test in a incremental way. Now last three are very interesting term, I would say. They are related to your reports and they are very basic. So first of them would be average response time. So whenever we do performance or load test, we will be running some number of users, n number of users, as I said, for some duration or steady state, let's just say 1 hour. So when we are doing so, whatever transaction we have defined for this particular test, they will be running repeatedly or in iteration. So we will always take an average of those iteration and say it as average response time. Average response time may or may not be giving you a right picture about your application's responsiveness. It might be good, it might be bad. So you know it's just a median of some samples, right? So you should not rely on only average response time. So the another matrix which we have to consider is 90 percentile response time. So what is 90 percentile? As all of you know that we will be having, let's just say we will be having a sample of 100 responses. We will be arranging them in a descending order. We knock off the top value and whatever will be the top second most, I mean the top second value, we will pick it up and say that is my 90 percentile. So basically 90 percentile is the confidence level what we can share with our customer, saying that hey, this is my 90 percentile and all other samples would be below these numbers, right? Another thing which most of us would have seen in performance reports but will not consider is standard deviation. So if you look at the numbers, standard deviation define the variation from your mean. The lesser would be the standard deviation value, your response time will be more stable. Let me repeat. If you have lesser deviation, your response time values are good. If you have more deviation, your response time for that application is not stable. So if you ask me, I would say you consider always all these three metrics written in the end, which is average response time, 90 percentile, and standard deviation. Combine them and see how the pattern looks. Never ever go with one value. For example, for some of the samples, you can say average response time is very good, and you will share it with your customer saying that hey, this is my response time. That is not a right value, because as I said, it's just a median. It might be, you might have some corner cases where response time has gone to extreme value and very low value, and then you take the average and show it to your customer. Likewise, even 90 percentile will give you some confidence level, but it is not always accurate. It might be showing you some good number, but your samples are scattered here and there. So you combine all these three. I will take another session or separate session on that with some examples and try to explain you. I hope this session will be giving you some basic idea of some of the terminology we will use in performance testing and help you in the forthcoming session when we have some demo classes. So stay tuned guys for the next session. Thank you so much. Have a nice day. And as I said, do like, share and subscribe to this channel and share with your friends who really want to learn performance testing. Thank you. Bye bye.